This is Dr. Sridhar, back to you with another video session on feedback characteristics. Why feedback is required in control systems and what are the advantages and limitations of these feedback sessions or feedback paths in control systems. Majorly, we are going to discuss on sensitivity and how the sensitivity it will be affected if the feedback is connected to open loop control systems. So basically, if you could recollect from the basics of control systems, now we have two types of control systems. One is open loop control system. Next one is the closed loop control systems. In the closed loop control systems, now we are going to take one signal from output and we are going to give it to the input by means of a feedback path. So the feedback, in what way that feedback is different from forward path means, forward path is always travels from input to output, and whereas the feedback is traveled from output to input. So if the feedback is connected, what are the parameters? What are the major electrical quantities it will be affected? In what way the feedback is adding benefits to the existing systems? And moreover, what are the major advantages of feedback control systems over open loop control systems? These are the things we are going to discuss in today's video session. So suppose first feedback is used to reduce the difference between reference input and the controlled output. Suppose feedback is nothing but, if you could observe in this particular closed loop control systems, now this E of S is nothing but that is an error signal. This is nothing but simply this is an error signal. Suppose before going to the closed loop control system, if you are taking the open loop control system, now just you give the input and the system it will process the input and some amount of input it will be transmitted to the output, that is nothing but the C of S. C of S is nothing but that is a Laplace transform of output, that is C of S. So here suppose if you are expecting an output of sub 50 volts for input of 20 volts, now we don't know whether we are going to reach that 50 volts if the input is 20 volts. Sometimes it may happen, sometimes it may not happen. We don't have any control over the output, whether the output is as per our requirement or not. So whatever the probability of getting the output as per our expectations means, very few or very less probability is there. In very rare cases, we may get our output as per our expectations. So now this is the major thing. It can be observed in the open loop control systems. Now, if the output is far away, if it is deviating drastically from the desired value, then at every moment, if you could adjust the output as per our requirement, that would be a better system. That would be our suggestion for the design engineers to develop a system like that. So that can be happened if instead of open loop control system, if you are moving to the closed loop control systems. Now in the closed loop control system, now one section we are going to connect, that is nothing but the feedback that will be taking the input from the output and it will be given to a summer point. This summing point, generally what happens, summer it should be connected whenever two input signals are traveling to each other. If you want to add two signals or if you want to compare two signals, a summing point is compulsory. So that is the reason here we are connecting a summer. So this left side is nothing but it will be input and this for this summer we are giving one more signal that is from the feedback. So the output of the feedback it will be given to the another plate of the summing point. So here what is this summer? This summer will compare the two signals. It will be given as error to the system. Now see, in the open loop control systems, directly straight away how much of input you have selected, that will be directly acting on the system. But whereas in the closed loop control system, error it will be compared or error it will be adjusted with respect to the feedback. That feedback is again, we have taken it from the output. So indirectly, the actual input which is acting on the system, it will be decided by the input and output. Input and output means output is how much it is deviating from the actual desired value. Now that value, based on that value and the actual input acting on the system, that error signal it will be adjusted. So that is the beauty of these closed loop control systems. In the closed loop control system, input doesn't act directly. Instead of input, one error signal it will be generated. That error signal is nothing but that is because of the output of the feedback and the actual inputs such that we are going to generate one error signal E of S. That E of S or that error signal, it will be the actual signal acting in the closed loop control systems on the system to process. Suppose if the output is too much, it is deviating from the actual value. So that will be processed by the feedback and that will be given to the summing point. Now at this particular one constant, what happens? Suppose there are two types of feedback control systems are there. One is the positive feedback control system. Next one is a negative feedback control system. If this plate is positive, if this two plates of the summer are positive, then that is nothing but the positive feedback control system. Suppose if one of the plate of the summing point is negative, that is nothing but the negative feedback control systems. So suppose here, now if nothing is given to the plate of that particular summing point, means you can assume it as a positive. Then another one is clearly they have mentioned here, that is a negative. So positive and negative. So this summer is nothing but the negative. One of the plate of the summing point is negative. So this system, this total completely closed loop system is nothing but it is a negative feedback control system. Suppose coming to the actual value here, if the output is completely deviating from the actual desired output, then that will be processed by the feedback and it will be given to the negative plate. So what is this error? It will compare the two signals, actual input and the actual output, what we are going to get it in time to time. That will be compared here. So the net difference will be the inputs actually acting on the system. So input have been changed from actual input R of S to E of S. So proportionally your output will also change. So how much the output means, again it will be taken as a feedback and it will be given to the summer. Here the summer again it will compare the two signals, input and the output of the feedback, and it will be again processed as a error, and it is a continuous process. So this will be comes to rest once the output, if it is satisfied or if it is as per our expectations, then this total process comes to rest. Until that particular instant, it will be continuously processed. So like that, in the closed loop control system, probability of getting the output as per our expectations is maximum. But whereas in the open loop control systems, the output, whether we are going to get the output as per our expectations or not, we don't know, and the probability is very, very less. So that is the things we have discussed so many times in our previous videos. That is nothing but that is the difference between open loop control systems and the closed loop control system. Basically, now if you are geometrically, if you could observe, what is this open loop control system, what is this closed loop control system means. In the closed loop system, additionally, two more blocks it will be added. One is the summing point and next one is the feedback loop. So the summing point, anyhow, it is required because whenever you are adding two signals, whenever you are comparing two signals, now a summer is required. So that is the purpose of keeping a summer in the closed loop control systems. Whereas in the feedback system means that is an additional block we are going to add in the open loop control system. Then the resultant will become a closed loop control system. So what is this feedback means? Now whatever it may be the internal components of the feedback systems, once the feedback system is connected to the open loop control systems, means indirectly the closed loop systems advantages, limitations, and how effectively the various parameters of closed loop control system by the adding of this feedback section. Now we are going to discuss various parameters. So the feedback is, once again I am repeating the statement for better understanding, feedback is used to reduce the difference between reference input and the controlled output, because the output is nothing but that is there, that is in our hand in the closed loop control systems, whereas in the open loop control system that won't be there in our hand. So once the input is switched on, automatically it will be processed, some amount of output it will be given in the open loop control systems. But whereas in the closed loop control system, you have to stop the system till that particular instant. You can process the input and you can observe the controlled output, whether the control output is as per our expectations or not. Till that particular instant, you can go on varying the output quantity as per our expectations. The feedback in control systems not only reduces error but also reduces the sensitivity and unwanted internal and external disturbances. So these are the two important parameters. What is this sensitivity and how this sensitivity it will be compensated? It means to say how the sensitivity it will be reduced in the closed loop control systems, and how can we reduce the impact or the effect of internal and external disturbances in the closed loop control systems. These are the two major parameters we can discuss in today's video session as well. So, what about the parameters? It will be varied. So, effect of parameter variations we can study in the open loop control systems as well as in the closed loop control systems. Similarly, sensitivity also in the open loop control systems and closed loop control systems. Third parameter is nothing but the effect of feedback on overall gain, effect of feedback on stability, effect of feedback on time constant of the control system. Last one is effect of feedback on disturbance. The disturbance could be a internal disturbance or external disturbances. These are the 6 important major variations we can observe, and these are the 6 important parameters that will be affected adversely once the feedback is connected. So if it is affected, then how effectively these 6 parameters it will be varied in the closed loop control systems. So first, if you could see effect of parameter variations. Now, effect of parameter variations, we are going to discuss, because if we are not talking anything about open loop control systems, then we cannot establish a perfect relation of the characteristics of the feedback system. Means feedback is nothing but that is the section, it only separates open loop and the closed loop systems. So that's why let us examine these 6 parameters, and let us study these 6 parameters for open loop systems and the closed loop systems. Once if we could do that, then only we can establish the perfect relation, and that is nothing but the effect of feedback section on these 6 parameters. So first one is nothing but parameter variations. So what are the parameters? It will be varied. Now that we are going to examine for open loop and the closed loop systems. So first, let me examine this open loop control system. In the open loop control system, that R of S is there and then C of S is there. So R of S is the input, and system transfer function, that is the forward path system transfer function, is nothing but the G of S. On the left side to that, I am giving R of S, and on the right side, we are giving as the G of S, C of S. So suppose due to some internal disturbances or due to some parameter variation, suppose if you could take a transformer, the transformer is an example for electrical parameter or electrical section. Because of certain variations in the temperature, once if it is kept during the summer, especially during the peak summer, what happens? The transformer has to withstand against to 53 degrees centigrade or 54 degrees centigrade. Now based on the geometrical area, geometrical constraints. Suppose the same transformer, if you could place in a winter, now the transformer need not address that much of temperature. So because of these temperature variations, or this moisture, or because of these rainy conditions, or because of seashore conditions, so many constraints are there. Because of these constraints, what happens? Sometimes internal parameters may be slightly adjusted, or it will be varied because of some various environmental conditions. So that variations we are assuming as delta G of S. That G of S is nothing but that is the actual system, that is the forward path transfer function of actual system is G of S. So because of some internal variations or because of some environmental conditions, let us assume the system parameters were varied by small changes. We can observe that the variations are nothing but the delta G of S. So G of S is nothing but the actual forward path transfer function. Delta G of S is nothing but that is the small variations in the forward path transfer function. So that's what a delta G of S is. Now, once the delta G of S is changed to G of S plus delta G of S, means these are the additional variations we are saying. So whatever the input won't change, but whereas output definitely it will be changed, because that input has to pass through that forward path transfer function, that is G of S. Once the G of S is changed to G of S plus delta G of S, so proportional to that, now output will also change. The output will be assumed as C of S plus delta C of S. The delta C of S is nothing but that is proportional to, or that is because of, not exactly proportional, but that might be because of that parameter variations in the forward path transfer function, that is delta G of S. So that's what here we are clearly mentioning. Delta G of S is nothing but the delta C of S. Means the delta G of S will make the change in outputs as delta C of S. So first, effect of parameter variations can be observed as, so we know that output is nothing but input into transfer function. Output, Laplace transform of output is nothing but transfer function into Laplace transform of input. So let us make use of the same concept here. So what could be the outputs overall once the parameter variations have been taken place? The output is nothing but the C of S plus delta C of S, which is nothing but transfer function, that is G of S plus delta G of S, and the input is nothing but R of S, because input won't change because the parameter variations have been taken place in the system. So not to the left side of the system. So on the left side what happens, R of S will be there, but in the system, that is G of S plus delta G of S. So only from that system onwards the parameter will be varied. So then automatically the corresponding consequences will be changed. So that is nothing but the output will be changed from C of S to C of S plus delta C of S. That's what clearly we are mentioned here. So delta C of S plus delta C of S is equal G of S plus delta G of S into R of S. Suppose if we are simplifying that, C of S plus delta C of S is equal G of S into R of S plus delta G of S into R of S. So on both the sides, some of the common terms can be cancelled. So remaining one is nothing but the delta C of S is equal to delta G of S into R of S. So what do you mean by that? So the changes, the parameter variations, the corresponding variations in the output is equal to the parameter variations in the forward path transfer function into system. So this is what we can observe in the open loop transfer function. Now straight away we can say that because now we won't have any control over the outputs. So how much of variations that have been taken place in the internal process, that is nothing but the forward path, that will, if it is multiplied with input, then that will be the output. This is what open loop transfer function is. So second one is the effect of parameter variations in a closed loop control system. Consider a closed loop system. Now we can say that closed loop control system is G of S it will have and H of S, and output is nothing but the C of S, input is R of S. So here the additional quantity is nothing but error, that is E of S. So the what about the overall transfer function? Overall transfer function of the system is given by C of S divided by R of S is equal to G of S plus 1 plus G of S into H of S. This is the overall transfer function if it is observed, if it is assumed as the closed loop control system as a negative feedback control system. Now let us assume this is in the total analysis we are going to consider as a negative feedback control systems only. So in the negative feedback control systems, whatever the overall transfer function, so that is C of S to R of S is equal G of S plus 1 plus G of S into H of S. So what are the variations? Let us introduce the variations in the forward path transfer function. So the proportional variations in the output is C of S plus delta C of S is equal to G of S plus delta G of S divided by 1 plus G of S plus delta G of S into H of S into R of S. Wherever the G of S is there, G of S plus delta G of S we have to add. So finally C of S plus delta C of S is equal G of S plus delta G of S divided by 1 plus G of S into H of S. In the denominator if we are simplifying, so delta G of S into H of S into R of S. So this delta G of S into H of S is a very smaller value as compared to G of S plus G of S into H of S. So as compared to this particular value, now delta G of S into H of S could be ignored because delta G of S is nothing but a very smaller value, and again H of S, if it is multiplied, then furtherly that value comes to negligible. So that's why, or in other way also we can put like this, that in order to simplify our assumptions, that delta G of S into H of S can be ignored. If it is ignored, then C of S plus delta C of S is equal to G of S plus delta G of S divided by 1 plus G of S into H of S into R of S. So this is the, after ignoring this delta G of S into H of S, so this total expression can be reduced into a simplified manner, that is C of S plus delta C of S is equal to G of S plus delta G of S divided by 1 plus G of S into H of S into R of S. So again here also, again in the numerator the delta G of S plus delta G of S is there. So you can separate G of S as a separate term and delta G of S as a separate term. That's what we are doing here. So C of S plus delta C of S is equal G of S by 1 plus G of S into H of S into R of S plus delta G of S divided by 1 plus G of S into H of S into R of S. So this total value is nothing but this is finally actually C of S value. This is the C of S plus delta G of S divided by 1 plus G of S into H of S into R of S. So on the left side and right side, there are some common terms are there. So if you are ignoring that, if you are cancelling the term, so left side is nothing but the delta C of S is equals delta G of S divided by 1 plus G of S into H of S into R of S. So this is the output corresponding to the internal variations in the system, parameter variations in the system, in the closed loop system. In the closed loop controls, in the open loop control systems, if you could observe, delta C of S is nothing but just delta G of S into R of S. This is what it is happening in the open loop control systems. In the closed loop control system, so this same delta C of S is equal to delta G of S divided by 1 plus G of S into H of S into R of S. So what do you mean by that? Closed loop variations is equals open loop variations divided by 1 plus G of S into H of S. So which one is reduces the impact of variations in the output? So no doubt it is closed loop control system, because open loop control systems is divided by 1 plus G of S into H of S. So generally G of S into H of S value is definitely it is a positive value. It is certainly very, very larger than 1. So open loop transfer function variations divided by very larger value. So that is nothing but the closed loop control system. So the impact of system variations on the in the closed loop control system on the output is very, very negligible. So this is nothing but it is a better feature that closed loop control system is having. Now here the observation is clearly just what we have described, narrated, the same thing we have clearly mentioned, that is delta C of S is equal to delta G of S into R of S is the open loop control system, and in the closed loop control system, delta C of S is equal to delta G of S by 1 plus G of S into H of S into R of S. From equation 1 and 2, that in a closed loop system, due to feedback, the change in the output due to the parameter variations is reduced by a factor 1 plus G of S into H of S. In an open loop system, such a reduction does not exist due to the absence of feedback. So this is a very, very important observation, and this is the effect the feedback system or feedback component on the closed loop control systems. Now, second one is the second important quantity is nothing but it is the sensitivity of a system, okay, control system. Sensitivity. So first, basically, we should have a doubt. Sensitivity is it should be maximum or it should be minimum for betterment of the system. Now, sensitivity should be minimum for betterment, because suppose if the sensitivity is too good or too good in the sense too high. Sensitivity is too high means for smaller deviations or smaller inputs also, if the system is behaving like anything, then is that property of a system is advisable for the betterment or for the healthy conditions of the system? No way. So that's why, so if the sensitivity is very high, so such property is not advisable for any existing systems. Generally, the sensitivity can be defined as percentage change in transfer function to the percentage change in any one of the parameter. So with respect to what parameter we are going to assess, or we want to assess the sensitivity of a transfer function, that should be there in the denominator. So sensitivity cannot be defined for only single parameter. Sensitivity means with respect to what? Because sensitivity can be defined in so many ways. The system is so sensitive with respect to temperature. The system is not that much of sensitive with respect to moisture. The system is not that much of sensitive with respect to some other conditions. So the parameter, the relation between the two parameters is very, very important. Between the two parameters only the sensitivity can be addressed. So that's what the sensitivity, if you want to define, sensitivity of what? With respect to whom? That is very, very important. So sensitivity of the transfer function with respect to the parameter, system parameter. So that's what here the sensitivity can be defined as percentage change in transfer function to percentage change in the parameter, which is nothing but the K. So how can we mathematically, we can also represent the sensitivity percentage change in transfer function is nothing but dou T by t. So dou t by t is nothing but that is the change in the transfer function divided by the percentage change percent. Now why that in the denominator the t came in means percentage we had to write, otherwise dou t is enough, but percentage means dou t by t to percentage change in k is nothing but the dou k by k. So if you are simplifying, if you are adjusting the numerator and the denominator, now this sensitivity can be represented as dou t by dou k into k by t, or k by t into dou t by dou k. So this is the definition for and the introduction for the sensitivity. So the representation STK is also called as the sensitivity function of a system. So here the same thing, let T of S be the overall transfer function of a control system, the forward path transfer function G of S vary. Suppose if you are observing or if you want to establish the relation between forward path transfer function and the overall transfer function, then what could be the expression for the sensitivity? So sensitivity STG. So that on the head side of this S, we have to write the major parameter on which the effect we are going to observe. In the down one, that is the G is there, that is subscript and superscript. In the subscript, the G is there. So that is the parameter we are going to vary, and in what way this parameter will influence the letter which was shown in the superscript. So dou t by so STG is nothing but the dou t of S by dou t of S divided by dou G of S by G of S. If we are simplifying this equation, G to T into dou T by dou G. So for the open loop control system, the same ratio if you could observe, let me calculate the transfer function. So in the open loop control system, the overall transfer function is nothing but the state of a G of S only, because there is no feedback, nothing in the open loop control system. So in the open loop control system, T of S is nothing but the G of S value. So STG is nothing but, so what is the expression just also we have represented, T of S to G of S into dou T of S to dou G of S. So this is the value here. So T and G both will be same. So the sensitivity of overall transfer function with respect to the forward path variations in the open loop control system is 1. So that is nothing but 100%. 100% means for anything, if you are varying any small deviation, for smaller deviations also the system will be responded like anything. So 100% it is so sensitive. That's the meaning of STG is equal to 1. The sensitivity of T of S with respect to G of S for the open loop system is unity. Now coming to the closed loop system, in the closed loop system, T of S is equals G of S by 1 plus G of S into H of S. Now if you are the same thing, STG, if you want to calculate here, now we are going to get this value as STG is equal to 1 by 1 plus G of S into H of S. This is what it is happening in the closed loop control systems. In the closed loop control system, is it 100%? No, 100% divided by 1 plus G of S into H of S. Now, which one is having low sensitivity? So, that is nothing but the closed loop control systems only. So, comparing equation 1 and 2, it can be observed that due to the feedback, the sensitivity function gets reduced by a factor 1 plus G of S into H of S as compared to the open loop system. Less the value of the sensitivity function, less sensitive is the system to the variations in the forward path transfer function. So if it is the sensitivity itself, it is less means now the impact of the system variations or system parameter variations on the response is relatively less. So that's why the sensitivity should be less for the betterment of the system. So again, in addition to the forward path variation, suppose here we may get one more doubt. If the variations in the closed loop control systems, especially in the feedback path also, if it happens, now that chance, that probability is also there. So that's why, so in continuation to that, let us examine the variations in the H of S on the performance of the overall transfer function, which is nothing but the sensitivity if you want to calculate. So that is STH, that is nothing but the subscript is H, superscript is T. So that is, if the variations in the feedback, so what would be the variations in the overall transfer function? STH is nothing but H of S to T of S into dou T by dou H. So the same thing. Now just let us take the first order differentiation with respect to H of the overall transfer function. So finally that STH is nothing but we are going to get the value as minus G of S into H of S divided by 1 plus G of S into H of S. So that is equation number 3. So if here the value itself it is negative, so that is sensitivity of T of S with respect to H of S, it can be observed from equation 2 and 3 that the closed loop system is more sensitive to variations in the feedback path parameters than the variations in the forward path parameters. So this is a very very important characteristics. If something went wrong, if for smaller variations in the feedback path, now that is not at all advisable. So the because we are getting negative, so much of deviation may be there. So that's why, so you have to keenly protect the forward feedback path in order to maintain the betterment of any control systems. So these are the sensitivity calculations and parameter variations. So I think it is very clear, and you people have followed what I'm telling. Thank you for watching this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.